Okay. We're going to pick up with Chapter 5. Like I said, Chapter 4 we just kind of skimmed through and talked about some of the key concepts that it goes over as far as what attributes are and how you have composite attributes, composite keys, and that kind of thing. So mainly it's just a little bit of terminology that I wanted you to kind of pick up in Chapter 4. We're not going to do an assignment from Chapter 4. So now we're going to pick up with Chapter 5. It's on advanced data modeling. The results of adding more semantic constructs to the original entity relationship model. You end up with your EER diagram or your entity or your extended entity relationship model diagram. Okay, so let's talk about entities, supertypes, and subtypes. Because most employees possess a wide range of skills and special qualifications, data modelers must find a variety of ways to group employees based on their characteristics. For instance, a retail company could group employees as salaried and hourly, while a university could group employees as faculty, staff, and administrators. If grouping of employees into various types provides two important benefits. It will avoid unnecessary nulls and attributes when some employees have characteristics that are not shared by others. It enables a particular employee type to participate in relationships that are unique to that employee type. Okay, so if we think about this, we end up with some modeling terms: entity supertype and entity subtypes. A supertype is a generic entity type that's related to one or more subtype. Alright? And the supertype contains common characteristics, and the subtype each contain their own unique characteristics. Okay, so two criteria help a designer determine whether it's a subtype or a supertype. There must be different identifiable kinds or types of the entity in the user's environment, and the different kinds or types of instances should each have one or more attributes that are unique to that kind of type or instance. Okay, so let's look at this again. Entity supertype, generic entity type related to one or more subtype. Okay, your supertype contains your common characteristics. Your subtype contains unique characteristics for each subtype. So the criteria that we'll go by determine if you use a sub or a supertype. There must be different identifiable kinds of the entity in the user's environment, and the different kinds of instances should each have one or more attributes that are unique to that kind of instance. Alright, so then we talk about something called a specialization hierarchy. Entity supertypes and subtypes are organized within a specialization hierarchy which depicts the arrangement of higher level entity supertypes, or parent entities, and lower level entity subtypes, which are child entities. Okay? The relationships depicted within a specialization hierarchy are sometimes described in terms of is-a relationship. For example, a pilot is an employee, a mechanic is an employee, and an accountant is an employee. It's important to understand that within a specialization hierarchy, a subtype can exist only within the context of a supertype, and every subtype can have only one supertype which is directly related to. However, a specialization hierarchy can have many levels of supertype-subtype relationships. That is, you can have a specialization hierarchy in which a supertype has many subtypes. In turn, one of the subtypes is the supertype to other lower level subtypes. Alright, so when you look at that, your employee is your supertype. It's just generalized characteristics of what an employee is. And then you have your pilots, and what was it gave you? It gave you pilots and mechanics and accountants. They are subtypes of employee. They are specialized to a specific job, a pilot, an accountant, but they're a subtype of employee because they still have the general characteristics of being an employee. Okay, it provides the means to support attribute inheritance. Let's talk about what inheritance is. The property of inheritance enables an entity subtype to inherit the attributes and relationships of the supertype. So all children of the parent can inherit from the parent. So your employee is your parent, pilot, mechanic, and accountant are all children. So your parent supertype employee has all these characteristics, and your subtype children, mechanic, pilot, accountant, can all inherit the qualities of the parent or supertype employee. Alright, you can define a special supertype attribute that is known as a subtype discriminator. The subtype discriminator determines which subtype the supertype occurrence is related to. It is common practice to show the subtype discriminator and its value for each subtype in the ER diagram. The default comparison condition for the subtype discriminator attribute is the equality comparison. Alright, then we're going to talk about some constraints. Disjoint, overlapping, complete, and partial. Alright, so an entity supertype can have disjoint or overlapping entity subtypes. In the aviation example, an employee can be a pilot, a mechanic, or an accountant. Assume that one of the business rules dictates that an employee cannot belong to more than one subtype at a time. That is, an employee cannot be a pilot and a mechanic at the same time. Disjoint subtypes, also known as non-overlapping subtypes, are subtypes that contain a unique subset of supertype entity set. In other words, each entity instance of the supertype can appear in only one of the subtypes. For example, an employee supertype who is a pilot subtype can appear only in the pilot subtype, not in any of the others, such as mechanic or accountant. On the other hand, if the business rule specifies that employees can have multiple classifications, sometimes they may have overlapping job classification subtypes. Overlapping subtypes are subtypes that contain non-unique subsets of the supertype entity. That is, each entity instance of the supertype may appear in more than one subtype. For example, in a university environment, a person may be an employee, a student, or both. In turn, an employee may be a professor as well as an administrator. Because an employee may also be a student, student and employee are overlapping subtypes of the supertype person, just as professor and administrator are overlapping subtypes of the supertype employee. This just gives you a diagram. Inheritance enables an entity subtype to inherit the attributes and relationships of the supertype. All entity subtypes inherit their primary key attribute from the supertype. At the implementation level, supertype and its subtypes maintain a one-to-one relationship. Entity subtypes inherit all relationships in which supertype entity participates, and lower level subtypes inherit all attributes and relationships from its upper level supertype. We done talked about the discriminator and the disjoint and overlapping. Alright. Completeness constraint specifies whether each supertype occurrence must also be a member of at least one subtype. Okay. Completeness constraint. let's talk about completeness constraint. Specifies, sorry for the interruption, specifies whether each entity supertype occurrence must also be a member of at least one subtype. The completeness constraint can be partial or total. Partial means that not every supertype occurrence is a member of a subtype. Some supertype occurrences may not be members of any subtype. Total completeness means that every supertype occurrence must be a member of at least one subtype. Okay, so here it shows some specialization hierarchy constraint scenarios where your supertype has optional subtypes. Or for your partial there, where your subtype sets are unique, and your discriminators can be null, and your total, every supertype occurrence is a member of only one subtype, and subtype discriminators cannot be null, and the sets are unique. Alright, so specialization and generalization. You can use various approaches to develop entities, supertypes, and subtypes. Specialization and generalization are some ways. Specialization is a top-down process of identifying lower level, more specific entity subtypes from a higher level entity supertype. Specialization is based on grouping unique characteristics and relationships of the subtypes. In the aviation example, you use specialization to identify multiple entity subtypes from the original employee supertype. And generalization is the bottom-up process of identifying a higher level, more generic entity supertype from lower level entity subtypes. Generalization is based on grouping the common characteristics and relationships of the subtypes. For example, you might identify multiple types of musical instruments, piano, violin, guitar. Using the generalization approach, you could identify a string instrument entity supertype to hold the common characteristics of the multiple subtypes. An entity cluster is a virtual entity type used to represent multiple entities and relationships in the ERD. An entity cluster is formed by combining multiple interrelated entities into a single abstract entity object. An entity cluster is considered virtual or abstract in the sense that it is not actually an entity in the final ERD. Instead, it is a temporary entity used to represent multiple entities and relationships with the purpose of simplifying the ERD and thus enhancing its readability. So this shows using entity clusters. It contains two: offering, which groups the course and class entity relationship together, and location, which groups rooms and buildings together. To make it more readable, is just group those together. Alright, so let's talk about primary key. A primary key uniquely identifies each entity instance. The primary key's function is to guarantee entity integrity. Furthermore, primary keys and foreign keys work together to implement relationships in the relational model. Therefore, the importance of properly selecting a primary key has a direct bearing on the efficiency and effectiveness of database implementation. The concept of a unique identifier is commonly encountered in the real world. For example, you use class or section numbers to register for classes, invoice numbers to identify specific invoices, and account numbers to identify credit cards. Those examples illustrate natural identifiers or keys. A natural key or identifier is a real-world, generally accepted identifier used to distinguish real-world objects, uniquely identify them. As its name implies, a natural key is familiar to end users and forms part of their day-to-day business vocabulary. Desirable primary key characteristics. Of course, unique values. Primary key must be uniquely identify each entity instance. It must be able to guarantee unique values and cannot be null. Non-intelligent, the primary key should not have embedded semantic meaning other than to uniquely identify each entity instance. No change over time. If an attribute has semantic meaning, it might be subject to updates, which is why names do not make good primary keys. If someone gets married, their last name will be updated, which would change all of your key information. Alright, preferably single attribute. A primary key should have the minimum number of attributes possible. Single attribution primary keys are desirable but not required. Single attribute primary keys simplify the implementation of foreign keys later on. Preferably numeric, unique values can be better managed when they are numeric because the database can use internal routines to implement a counter style attribute that automatically increments values with the addition of each new row. Security compliant, the selected primary key must not be composed of any attributes that might be considered a security risk, such as social security numbers. Use of composite primary keys. Identifiers of composite entities. Each primary key combination is allowed once in a many-many relationship. Identifiers of weak entities has a strong identifying relationship with the parent entity. Okay. Okay, so composite keys are permitted, even though they're discouraged. And here, like I said, here's your where it is useful. When used as identifiers of weak entities, you represent a real-world object that is existence dependent on another real-world object and represented in the data model as two separate entities and a strong identifying relationship. For example, a real-world invoice object is represented by two entities in a data model, the invoice and the line. Clearly, the line entity does not exist in the real world as an independent object, but is part of the invoice. Surrogate keys is a primary key created by the database designer to simplify the identification of entity instances. The surrogate key has no meaning in the user's environment. It exists only to distinguish one entity instance from another. One practical advantage of a surrogate key is that because it has no intrinsic meaning, values to it can be generated by the database management system to ensure that unique values are always being provided. The design cases, we're not going to go through these. I think that will finish up the chapter. If you want to go through the design cases, go right ahead, read through them, look over that. Let me know if you have any questions. Again, chapter 5 is a lot of terminology and examples, so read through it, and if you have questions, let me know. There will not be an assignment on chapter 5. It's just mainly, again, like chapter 4, some diagrams you need to look at and some terminology you need to be familiar with.